From now on, we are going to be developing our robot, the Big Bazoo, and it is going to be following a structure that we discussed in the URDF theory portion. Let's create a folder inside of our package. Right click, new folder, URDF, Unified Robot Description Format. All of the URDFs are going to be carried inside of this specific folder. I'm going to create a new file inside of it, Big Bazoo dot URDF. URDF is the extension we are going to be using, and now we are going to develop our robots parts by parts. Okay, you are going to see an important concept of autofilling that the extensions we installed are going to perform for us, and that will make our life a lot easier. We'll start with the robot. I just type ROBO. It is going to provide me a lot of things. I will select the first one. It has automatically completed some tags and asking me for the name of the robot. I'm going to say Big Bazoo, and that's enough. The syntax is completed, but we need to define some links and joints. The first link is going to be simple link, and the name is going to be world. As we discussed, it is not going to be a fancy link. It is just going to contain the world name. It is basically origin. Okay, from now on things are going to get complicated because we are going to create some complex things. I'm going to type link, and it is going to provide me a lot of options. I'm going to select link full, and you can see a lot of code has automatically been produced. This is the power of raw snippet plugin. I'm going to delete certain things that I don't need. This origin, and texture name, file, and origin of collision as well. To some extent, this is what I need currently. Although for RViz, I just need this visual tag. I don't need this collision tag nor the inertial tag. So I will leave them empty. Okay. Name of the link is going to be base link. What type of visual body it is going to be containing? It is not going to be a box. It is going to be a cylinder. Okay. And again, it automatically completes what radius and length is, the parameters of the geometry. Important point here is these are syntax followed by the URDF, and this snippet automatically provides us with our life gets easy. I'm going to create a joint. It is going to be a joint full, and again code has been automatically produced for me. The joint name is base joint. It is going to be a revolute type, an actuated type. Its origin is going to be 000. Parent link is world. Base is child link is base link, and the axis and the joint limits. Although it is not going to be a revolute, it is going to be a fixed type, so we don't need the axis, neither these limits. This is a basic structure for our first link, and you will see that how does it looks like. Let me first give it a radius of 0.2 and length of 0.05 or radius of 0.05. That would be fine. Now Control Shift P, open up the command palette, and I'm going to search ROS. In ROS, I need to select preview URDF. It is going to generate a preview. Okay, you can see you can see there is this small bar apparent in this whole simulation world, sort of this preview URDF. I am going to change the values, radius to be 0.2 and length to be 0.5. Let's see how does it looks like. It's very big, and now it is fine. So what is happening? We are making changes in the code, and what apparently it is representing is displayed with the help of this URDF preview, an awesome extension by Microsoft. and that makes our life easy. Why it is red? Because the color is RGBA and R has been set to 1. If I change it to be 0 and set green to be 1 and save it, its value is going to change. I don't know why it is not rendered green. It changed into black. But you change these RGB values, the value of the color or value of this preview changes. Okay. Control Shift P and preview URDF. Now there is a problem with this thing. That's why the color was not applied. It is, I deleted the material tag. Okay, now it is fine. If I make changes 0.01, save it, and you can see it has now turned green. Okay, that was interesting. Now let's create more joints and more links. I am going to paste some code that I already copied, and it is going to make a lot of sense if I save it and see the output. So in your perspective, what do you understand out of this? There is a bar and there is a ball. Is it a ball? No, it is a cylinder as well. How does it make sense? Let me show you. Link number 1 has been created. In link number 1 we have a specified geometry, and that geometry is of this length and this radius. This bar has been created. RGB, it is a blue, and A is for apparent. It is a blue bar of this length and this radius. Origin is this. Collision values are same as the visual values of the geometry. So these values are same. Inertial values are randomly given. They are not accurate, by the way. So we will see how to accurately calculate the inertial values for all of the joints. Let's leave it for now. Then there is a joint. It is a continuous joint. I would set it to be revolute because revolute is more appropriate for such type of robots, as we need specified positions for the joints. We don't want it to be continuously rotating. Axis is what we will explore when we will be discussing RWAYS and joint state publishers. Parent is base link, the important point. Child is link number 1, and there is a offset in the XYZ. If I remove it, and now you will see the effect here in this preview, Control S, and you can see the bar moved a little bit downwards. If you did not see it, let me increase it with a large value, and you can see in the Z axis proper offset has been applied to the body, to the child body from the parent. So I will undo it and apply the appropriate offset that is required. In link number 2, it is again a cylinder of this length and this radius. It is of red color, and to me this red is a little bit off, so I will set it to be 0.0 and give it a name black. Now let's get back to the point. Link number 2, inertial values are given. We will discuss them later. Visual, cylinder, radius, color red, and length of the cylinder and radiuses are provided. Collision is the same as of the visual tag geometry. Joint is again continuous. Why, I don't know. I have written joint continues again and again. Axis is what we will discuss when we will be dealing with RWAYS. Parent is link number 1. Child is link number 2. There is an interesting offset here, and you can play with these values and you will see the output. If I remove this 90-degree rotation, let's see what happens. The cylinder rotates to a point where it becomes useless, so I will give it a rotation of 90 degree. All of these values are properly adjusted manually by me and then proposed to you in this course. There is a limit also applied that will make sense when we will be dealing with RWAYS and see its output. So basically you now understand how a URDF can make a robot. Although it is not complete, I will complete in the next part how it is going to make more sense like a robot, and Arviz is going to help us understand what this purpose of this robot is going to be with the help of transforms.